Hey guys, so today we're going to be going over our system called FitTrack. My name is Vic Castillo.
My name is Cameron McFall.
And my name is Colby Papadakis.
So for our agenda, we're going to be starting off by going over the project overview and then the two architectural styles we implemented, client server and layered-based architecture, the pros and cons of each one, finally our selection, and then a quick demo of our system. So starting off with the project overview. So our app called FitTrack is a workout tracking application designed to help users monitor their fitness journey. So users can log detailed exercise information like sets, reps, weights, durations to build a more complete training history. We have a central dashboard feature that serves as the user's hub and displays recent workouts, active goals, and things like that. And then our goals feature allows users to set and track milestones with real-time progress bars to um, that update automatically to kind of visualize milestones. And then another key feature of FitTrack is the continuous feedback loop. So basically, every workout logged immediately updates all analytics and progress visualizations. Starting off with our first architectural implementation. So we picked client server for several different reasons, as you can see here. So starting off with clear separation of concerns. Um, as you can see in the component diagram that we have here, we have a React client that handles all user interface and presentation logic. And then the Spring Boot server over here manages business logic, data processing, and database operations. So this clear division makes our code base easier to maintain and separates front end and back end development. Secondly, our straightforward request response flow. So when a user logs a workout or checks their progress, the client sends an HTTP request to the server, which processes it and then returns the data immediately. So this pattern flows well with how we want users to interact with FitTrack. They expect to see the workout saved and the progress charts updated instantaneously. Third, our scalability. So using REST APIs with the stateless server, we can horizontally scale and add more servers to serve more clients without changing the structure of our entire system. Direct database operations. So the server's layered architecture with controller services, repositories, and entities provides efficient database access to our Postgres database. So when a user logs a workout or retrieves their history, basic CRUD operations are done without the overhead of things like message queues or event processing that other architectures might require. Lastly, availability. So again, with our centralized server managing all data, we can implement really robust backup and recovery strategies in case servers fail or any other issues arise. So as a result, users can rely on their working data being consistently accessible whenever they need it. So these factors combined really made client server a good choice for implementing our core functionality. So now looking at this component class mapping diagram, so this diagram really maps our architectural components to the actual classes we implemented. So the client here over here shows our React components like login screen, dashboard screen, goal setting screen, which communicate with the server through API services. And then our server tier over here is organized into three different layers. We have the presentation layer over here with our REST controllers. These handle HTTP requests. The data access layer over here, repositories that perform basic CRUD operations, and then finally the entities layer over here contains our domain models like user, workout, goal, and exercise, and those map directly to our database tables.
This diagram shows the client-server architecture with two sides, client and server. On the client side, we have React components, so app, login screen, dashboard screen, workout log screen, goal setting screen, and profile screen, which handle UI and user interactions. They use API client to make HTTP requests to the server. And on the server side, we have REST controllers, so user controller, workout controller, goal controller, and these handle HTTP requests. They use repositories, user repository, workout repository, and goal repository to access data. And the repositories manage entities, user, workout, goal, and exercise, which map to database tables. Communication flows across an HTTP boundary. The client sends requests, the server processes them and returns responses. This emphasizes horizontal separation across the network, with the client handling presentation and the server handling business logic and data persistence. So we didn't use event-based architecture for three reasons. First, unnecessary async complexity. Event-driven systems use queues, handlers, and eventual consistency. Our app needs immediate actions. You need to log in and get data right away, save a workout and update goals immediately. Second, there's a complex setup. Event-based systems require producers, consumers, message brokers, and handling out-of-order events. Our app is mostly basic CRUD, create users, log workouts, update progress, so this setup is going to be overkill. Third, delays and complexity. Many actions need immediate consistency, like saving a workout and updating goals together. Event-based architecture would introduce delays and complexity that we don't need.
With that all being said, we decided to implement the layer-based architectural style. The reason why we chose to go with layered architectural style is because of five reasons. The first one is the separation of concerns. Layered architectural style organizes the code in a distinct vertical stack style, which is on top of each other, where each layer has a specific job and communicates only to the adjacent layer. The second is modulatory reasons, and each layer, front end presentation layer, service, respiratory, and domain, and date in the database can be developed and tested and modified independently without affecting one another. This also goes hand in hand with helping with testability and making sure that everything can be tested independently of each other. The third reason is maintainability, where we're able to modify certain parts of the layers without like affecting anything like making changes to goal calculations, etc. The fourth reason is for security reasons. We use data transfer objects, DTOs, to filter out sensitive information since we're handling like health data, and which is very important for FitTrack to keep those data stored and secure. Um, Next, we'll go on to the class diagram, where we'll start with the first layer, which is the front UI layer. We have five screen components, which is the login screen, dashboard screen, workout screen, and goal setting screen and profile screen. And these are all referenced to the API client where it handles all the HTTP communication with the backend. The second layer is the presentation layer where we have our Spring Boot controllers that are shown in blue. Um, with and everything. The third layer, which is in green, shows the business logic, where we have our user service interface where it defines the contract and what the operations are available. This is implemented in the user service implementation, which can change the actual business logic, which goes in the same for the workout service, the goal service, etc. This is all connected through the data access layer, which is connected to the facade uh, class that we see. This brings like a clear line of communication between the data access layer and uh, business logic layer. So in the data access layer, we have our DOTs, the data transfer objects, and the mappers and the respiratories. Uh, and then connected to the data accessing layer is the actual database where we implemented Postgres, which shows our domain module which in pink, which shows the entities user workout and goal and exercise.
All right, now looking at the component to class mapping diagram for the layered architecture. This diagram maps architectural components to the implemented classes. The front end layer shows our React components, so app.tsx, login screen, dashboard screen, workout log screen, goal setting screen, and profile screen, which communicate through API.TS helpers that make HTTP requests. The presentation layer contains the REST controllers, user controller, workout controller, and goal controller that handle HTTP requests and delegate to services. The business logic layer includes service interfaces and implementations, so user service, workout service, and goal service that encapsulate business rules. The data layer combines mappers, DTOs, repositories, and entities, with user mapper, workout mapper, and goal mapper converting between DTOs and entities. User DTO, workout DTO, and goal DTO defining data transfer objects. User repository, workout repository, and goal repository providing database access by Spring Data JPA, and user, workout, goal, and exercise entities mapping to database tables. Note that mappers and repositories are merged into the same data layer to prevent layer bypassing, ensuring that services access both through the same architectural boundary. So now we'll move on to the pros and cons of both architectural styles. So starting with the pros, so client-server architecture has three key advantages. The first one is simplicity. Direct request response communication is straightforward to understand and implement. The second is centralization. All data and business logic reside on the server, providing a single source of truth. Third, efficiency. Clients offload processing to the server, reducing client-side resource requirements. These benefits make client-server architecture a solid choice for our fitness tracking application.
And for the layered architectural style, security is one of the pros of it. So we use DOTs, which is the data transfer object, to prevent password exposure. Um, when the front end requests the user data, we return the user DOT and not the entity. Should this should help keep the password safe in the server. The second is easier maintenance and change. So when changing the business rule does not affect the other controllers. And the third is separation of concern, which the business logic is centralized in the services and it's not scattered in different controllers like the client server. And then the fourth is excellent testability. The service layer can be unit tested without spinning up the database.
Okay, so now moving on to the cons. Client-server architecture has three main disadvantages. The first is bottleneck. The server can become a single point of failure and a choke point, reducing throughput under a heavy load. The second is coupling. So clients are tightly bound to the server's API and data structures, so server changes can break client functionality and require coordinated updates. The third disadvantage would be latency. Every request involves a round trip to the server, which adds delays compared to local processing. These limitations are important to consider when choosing an architecture.
Okay, so for the layered, one of the cons is the more initial development time. So creating a separate layers requires more boilerplate code. So for like every domain, user, user entity, user ID, etc. It's just requires more code. And with that, the second thing is more complexity, which the additional layers and abstraction means more files to navigate through and more code to understand. Third is the potential over engineering, which with this being a very basic application, this style can be a little bit excessive just with the amount of abstraction layers. Uh, yeah.
So after implementing both architectures, we chose layered architecture as our final implementation for FitTrack for these key reasons. So starting off with complex business logic. So with client server, all of our workout validation, goal tracking, and progress calculations would be put into like one monolithic server. So layered architecture better organizes complexity with controllers routing requests, services handling business rules, and repositories managing data. So it doesn't just separate between client and server. It kind of separates the back end more. So building on this, we go into separation of concerns. So again, While client server separates the front end from the back end, the layered architecture extends this by actually separating the back end into different layers. So each layer has a responsibility, and changes in one layer, like switching our database implementation from, say, Postgres to MySQL, would only affect the repository layer and not our entire server code base. Third is testability. So this is one big advantage that we thought Layered had over client server. With our layered implementation, we could unit test business logic in isolation without HTTP requests or database connections. Client server sometimes required full integration tests, but with Layered, we could test individual layers independently and with faster execution. Finally, long-term maintainability. So as FitTrack grows, with client server, with its inherent monolithic backend structure, it can be hard to refactor. So layered architecture prevents this by having a more flexible structure, and it follows Spring Boot conventions, which allows developers to contribute and for us to scale specific layers independently. So overall, while client server gave us the right overall structure, layered architecture provides a more provided better internal organization, which allows us to eventually build FitTrack into a more complete and professional application.
Now we'll walk you through a demo of FitTrack. Okay, so here is FitTrack. Now the first step to getting started with FitTrack is to register an account. So I can click on that. I can put in my information. So first name, last name, username, email, create a password, confirm it, put in all my personal information. So date of birth, gender, put in my height in inches, my weight in pounds. I can select my fitness level and then create an account. Now, upon creating an account, I am directed to the FitTrack dashboard. From here, I can navigate over to the goals page. Now, the key functionality to FitTrack is your ability to set a goal, log a workout, and based off that logged workout, track how close you are to achieving your goal, how much progress you've made along the way. So I can set a few goals over here. I'll start by selecting exercise. So bench press. Let's say I want to do 10 reps of 100 pounds. I can set a target date. I can add that goal. As you can see, that is then moved over to active goals. I can also, let's say we want to create a running goal. Let's say I want to run a 7-minute mile. I can click add goal. You can see them right there. And also if I navigate over to the home page, you can see the goals progress page. The goals progress section has been populated with those same goals as well. So now what I'll do is I'll navigate over to the workout page. So now let's say I'm in the middle of a workout and I want to track what I do. So let's say I start out with bench press and let's say I do one set of 6 reps for 100 pounds. I can add that exercise to the workout. Now let's say I go on a run and let's say I take 9 minutes to run 1 mile. I can go ahead and add that to the workout. And now that the workout is complete, I have nothing left to do. I can click save workout. You can see it's right there. If you go over to the dashboard, you can see it got thrown right there as well. And now if I navigate over to the goals page, you can see that these active goals, bench press and run that we created previously, their progress has been updated accurately. Um, Now, if let's say I achieve a goal, so take bench press for instance. So let's say in another workout, I hit the targeted volume of 10 reps for 100 pounds. Let's say I click add exercise to workout, save workout, gets thrown down there again. If I navigate over to goals, you can see that that bench press, because it was achieved, it got stripped out of active goals and archived in completed goals. Um, So yeah, that's how this works. You create a goal, you log a workout, and based off that log workout, you're able to see how much progress you've made towards achieving your fitness goals. Now, if I navigate over to the profile section, I can see all my personal information, and I can log out at the bottom over here, directing me back to the login page.